Have you ever wondered how shell scripting in Linux works? Let's unravel this mystery together. Shell scripting in the world of Linux is a potent tool that automates tasks, making our lives easier. To understand it, we first need to dissect the term. Shell is a user interface that accesses the services of an operating system. Scripting, on the other hand, refers to writing a sequence of instructions, or a script, executed as a single entity. Now that we've got a basic understanding of what shell scripting is, let's dive deeper into how it works. The first step to understanding shell scripting is knowing about the command line. The command line, or terminal, is the heart of Linux. It's a powerful tool where users can execute commands and interact with the system. Think of it as the control room for Linux. Now, what is a shell script? Simply put, a shell script is a series of commands for the shell to execute. It's a text file containing command line instructions. The beauty of shell scripting is that it allows you to automate repetitive tasks, making your work more efficient and error-free. A shell script can range from a few lines of code that automate simple tasks to complex programs. You can write scripts for task automation, program execution, and even for system administration. Once you have a grasp on the command line, you can start writing your own scripts. And that's where the real fun begins. Now, we will discuss how to write a basic shell script. First off, we'll need to open a text editor. You can use any text editor of your choice, but for today's demonstration, we'll use Nano. To open Nano, simply type nano in your terminal, followed by the name of your script. For instance, nano myscript-shay. Now, it's time to write our script. Let's start with a simple one. Type echo hello world. This will print the text hello world when the script is executed. Next, save your script with a sh extension. This tells the system that the file is a shell script. In Nano, you can do this by pressing Ctrl+O, then Enter, and finally Ctrl+X to exit. Now, we need to make our script executable. This is done by changing the file permissions using the cmodi command. Type chmod plus a myscript into your terminal. But wait, we've missed something important. The shebang line. This line, #bin/bash, tells the system which interpreter to use to execute the script. It should be the first line of every shell script. So, go back into your text editor, add #bin/bash at the top, and save the script again. And there you have it, a simple shell script ready to be executed. Now that we have a script, how do we execute it? Well, to run our shell script, we'll need to make use of the command line. First, navigate to the directory where your script is located. Then, to execute your script, type followed by the name of your script. For example, if your script is named myscript.ih, you would type myscript.ih. But wait, before you can run your script, you need to ensure you have the correct permissions. This is where the chmod command comes in. By typing +x myscript.ih, you grant execution rights to your script. The +x means you are adding execute permissions. If you forget this step, you'll likely encounter a permission denied error. Therefore, to execute a shell script, remember the two key steps. Navigate to your script's directory and ensure you have the correct permissions with the chmod command. Once you've executed your script, you've successfully completed your first shell scripting task in Linux. Let's quickly summarize what we've learned today. We started off with an introduction to shell scripting, highlighting its importance as a powerful tool for automating tasks in Linux. It's not just about executing commands, but also about creating scripts that can perform complex tasks efficiently. We then moved on to understanding the basics. We discussed the different types of shells and their uses, the structure of a shell script, and the importance of the shebang line. Next, we dove into writing a simple shell script. We learned about variables, control structures, and how to make our scripts interactive by accepting user inputs. Lastly, we executed our script, watching our code come to life. We learned how to make a script executable, how to run it, and the importance of debugging for troubleshooting errors. Remember, practice is key when it comes to mastering shell scripting. Happy scripting!